Hi everyone, it is Dr. Cari Peters here talking to you today about some fun stuff related to Fertilizer 101. So as you all know, I am a part of my family's company and my title is Master Crafter and Formulator of Jack's Fertilizer. So thank you for joining me today and let's start talking about some fertilizer basics. Maybe. Okay, so a lot of times we get asked questions about just things that people always say, this is a stupid question, but I'm going to ask it anyway. So there is never a stupid question. And we were kind of thinking this would be a great way to get some of the basic information out there of what's important to when you're looking at fertilizers, talking about fertilizers, or understanding fertilizers in general. So here we go. And just in case you don't know where I'm from, my company's name is J.R. Peters. I'm the third generation of this wonderful family business located here in Allentown, Pennsylvania. We are the formulators, manufacturers, designers, producers, everything to do with Jack's. So Jack's Classic for retail, Jack's Professional for greenhouse growers, and Jack's Nutrients for controlled environment and cannabis and hemp. All right, so when we talk about fertilizer basics, one of the most important things I think, in my perspective, as the formulator, the person that puts things together, is thinking about fertilizer as plant food. So back in the day, people always says, oh, feed your plants, so you're going to feed them plant food. But as we kind of moved through the decades and generations, we got away from that plant food kind of word and into, oh, this is fertilizer. Well, I like to always think of things as plant food because I look at nutrients as essential things for plants to grow. So this is a neat little kind of chart that shows you the macro, micro, and secondary nutrients, and not only their element, but also the form that they're absorbed by the plant. So when I think of fertilizer, if it's mineral fertilizer or organic fertilizer, I'm always thinking of the form of the nutrient that the plant is taking up. So this is a really neat kind of way to look at things when you're considering your overall plant health and feeding your plants with any type of food. So just to go further than that, we're going to talk about some of the basic information on a fertilizer just by pulling apart our Jack's bag. So all the things you see on here that I pulled apart are required to be labeled on a bag by a group of individuals called AAFCO, the American Association of Plant Food Control Officials. So again, it's not just to a Jack's product, it's every fertilizer out there, organic or mineral or otherwise, are required to have these essential information on it. And just by talking about these and pulling it apart, I think it'll give you a really great insight of the basic info that is important when you're kind of getting used to how to talk about and think about fertilizers and your plant nutrition. All right, most importantly, we're going to talk about some lingo. And right here is a really important thing to start with. The difference between percent and parts per million. They're actually related. 1% is equal to 10,000 parts per million. This is super important because you'll see when you look at labels, some things are labeled in percent sometimes, and some things are in parts per million. But you can easily make that conversion by using the 1% equals 10,000 parts per million. And parts per million in itself means that there's one part of one thing in a million parts of another. So that distinction there between percent and ppm are really important when you're looking at fertilizers and fertilizer concentrations. If you see here, and this is a slide that's kind of filled with crazy information, but you'll see how it's kind of broken up. So the top is just some examples of a nutrient range of nutrients in plant tissue. And you can see the NPK, calcium, magnesium, and sulfur. That's the macro and secondary nutrients. Because they're required in much higher concentrations in plant tissues, they're usually always put in percent. But then when you go to the micronutrients, the trace elements, the things that are required in a lot lower concentration, that's when you get into parts per million. But you can easily make the switch by moving the decimal point over and moving that to percent. So 90 parts per million of iron that you see there in a basal would be 0.009%. So it's kind of just something for you to keep in mind and how these things are related. On the bottom, you'll see that this is one of our examples of how we put together our nutrient targets for fertilizer solutions here at Jax. And all of that information when you're looking at fertilizer solution is most always in parts per million. So you'll see the big difference there, the percent and parts per million. Okay. And here's another neat way to look at things. You see the breaking down between the macronutrients and micronutrients, and you'll see the adequate tissue concentration of the macros and secondaries are much higher than those of the micronutrients. And it also gives you a cool little, snippet of the plant function of what these nutrients do in the plant. So it's a kind of neat way to look at it. But when we're looking at fertilizers and building a combination of nutrients to feed your plant, we look at, the forms available and how much the plant needs. But also what's really important is we look at the ratio. So you'll see here is a cool little table that shows some of the typical ratios we shoot for when we're developing different combinations of nutrients in one bag. So that's all the types of things I think about as a formulator on a daily basis. And it's kind of cool. It's like, when I was younger, I loved chemistry, but not in this type of way. This is more like the alchemy of putting things together, of doing this recipe to try and make the plants grow in their most optimal way. So it's cool to kind of see it all come together. All right, so let's go back to the bag. Again, you can find a lot of basic information about all plant nutrition and fertilizers on a bag of fertilizer. So the first and most important thing is the guaranteed analysis. This is basic stuff, guys. You need to know what is in a bag of fertilizer, and that's what you get from the guaranteed analysis. So you'll see the percentage breakdown, mostly it's in percent, of the powdered things that are in the bag. So you'll see the name and the grade, which is the formula there, the 20-3-19. That's percent N, percent P2O5, and percent K2O. And that tells you the most important information on what you're delivering. And then you'll see the breakdown of the secondary nutrients and the micronutrients. And it's all in this guaranteed analysis. So usually it's very prominent on the front of the bag. Also important, not only the percents of those nutrients, but where they came from. What forms did a formulator use and a manufacturer choose to get their nitrogen from, to get their phosphorus, to get their potassium? So underneath the guaranteed analysis is the derived from statement, and that really does give you a snapshot of the exact nutrients that are used to build this fertilizer. Pretty cool stuff when you think about why people choose different ratios and forms of nutrients. And one of the things that was just that a lot of people ask us all the time is what's the difference between a peat light formula and a general purpose formula? And that honestly has to do with the micronutrient concentration. So you can kind of see here that it's broken down in two ways. The top part shows you the percent of micronutrients, and then the second part shows you the parts per million when you're feeding at 100 parts per million nitrogen. But the big difference, whenever you see a formula that says peat light versus general purpose, peat light has to do with an enhanced or boosted micronutrient package. And it came back in the 1970s when growers started to step away from sterilized soil, root zone media, things to grow plants in sterilized soil, into this constructed media, which was soilless media. And what the researchers found, and mostly this was done at Cornell, they found that these soilless constituents really needed more micronutrients in order to provide the plant with all the nutrition that it needed. So that's when manufacturers of fertilizers, like my grandfather and like our family, came up with adding an enhanced micronutrient package. And that's why you still to this day see peat light formulas. All that means it's an enhanced micronutrient package. So here's another thing that I think is super important. When you look at derived from statements, you may see lots of different words in there and you're like, what the heck does it mean? And people get nervous when they see certain things. So one thing is in the form of nitrogen. Oh, there's always this kind of thought that urea is something that's not good for your plants. And that's not 100% true. Back in the day when urea was chosen as a nitrogen form and it didn't have all of the processes correctly to kind of clean it of all the byproducts and things you didn't want, urea used to come with a byproduct called biuret. And this form of the urea process, the plants didn't like it that much at all. And you would see burning, and it's mostly due to this byproduct of biuret. But that was in the 1960s. And between the 1960s and today, manufacturers and processors have done a much better job of cleaning the urea. So the form of nitrogen you get when you're purchasing or using urea and nitrogen does not have any of that biuret in it. So you really don't have any worries about having burning due to a form of nitrogen of urea. So lots of times when I'm choosing it, I only use it on formulations that will be mostly used in warmer weather. We don't really choose to use it in all year round formulations. We stick with more of a 60% nitrate, 40% ammonia based nitrogen. Another really cool thing to look at is the keywords that you have to stay away from. One is muriate, and that is just a code word for chloride. And that basically means that if you see something that says muriate, that form has excess chloride in it. And that's not something that you want to have in the balance of the root zone. Again, another word to look out for is soda. And soda is just another kind of hidden word for sodium. So again, if you see muriate or soda in the derived from statement, that kind of shows you that there's choices being made there that aren't really the best for plant nutrition. So it's just interesting to see that, and you can pick that all up from the derived from statement. And lastly, micronutrients. You can see a lot, if you see in the derived from that's on here, you can tell that this formula was made with something called EDTA. Those are chelates, and they keep micronutrients stable over a wider range of pH, usually from a little bit below 5 all the way up to a pH of 9. Some of the chelates are stable up to a pH of 9, but something like EDTA is usually stable and available for the plant to take up to about a pH of 6.2. When you're seeing something like a sulfate, they have a much lower pH availability and usually top out around 6.0. So that's just interesting information that you can pick up from the derived from statement. One thing you can't find out, and this is what's really hard, is heavy metals and some trace elements. And these are things that aren't put on the label, but so important. Heavy metals like lead, arsenic, cadmium, mercury, what was the other one? Lead, arsenic, cadmium, mercury, even a little bit of fluoride that can be in your water. It's not as much in your fertilizer, but you see these things in there, and it is not good for your plant to take up, especially if you're growing anything edible like basil, lettuce, any medicinal crops. Heavy metals are extremely toxic and can accumulate in the plant tissue. So the best advice I have for you is to go on, remember I said that regulation group called AFCO, American Association of Plant Food Control Officials. Look up your fertilizers on there and check for their heavy metal analysis, and that will give you a kind of clue in if this manufacturer is looking for these heavy metals in their choices of raw materials. All right, so let's go back to the back. So we talked about the guaranteed analysis, we talked about the derived from statement, but there's all this other information that's on there that's super important that we can take a look at. One of the neat things that each manufacturer has on is the directions for use. So the directions for use will give you the parts per million on there, so you can kind of see, kind of see what you need to mix up and the fertilizer rate that's important. But it also can give you an idea of if you're going to have some issues during mixing in concentration. So you can see that information right there. And it also gives you a value of electrical conductivity, so you can see. But mixing mistakes are a huge issue, and the most important ones that you can see when you're mixing fertilizers is a big no-no is keeping calcium away from two things: phosphorus source and a sulfur source. So it's very difficult when you're mixing things in concentrate. You cannot mix a high phosphorus formula like 10-30-20 with a calcium containing fertilizer, or you will get this white kind of snow globe material. And then the other one is calcium and sulfur. So you can't mix a calcium containing fertilizer with something like Epsom salts, because again, that will form, you see that hand there with the white material on it, that'll form gypsum. It really truly is a chalky-like substance in the bottom of the tank. So super important to follow those rules when it comes down to mixing things in concentration. Keep calcium away from sulfur sources and calcium away from phosphorus sources. Once you make this mistake, you'll never do it again. But the other thing is it can't be kind of turned around. So once you do mix these things together and it happens in the tank, the only way that you can kind of get away from it is to dump it and start again. It won't go back into solution in any way. All right, another question we get asked all the time is dye. Why is there dye in fertilizer? So really dye, it's just an indicator solution to show people that, hey, this water has fertilizer in it. And it was an old school way to kind of, show farmers out on the farm to not take a drink out of the hose. If you see the water a little more blue than normal, then that just shows that it has fertilizer in there. You would think that people would be able to taste it, but that's not always the case. We actually get a lot of calls here at J.R. Peters of people accidentally drinking fertilizer that maybe their husband or wife put in the refrigerator to kind of keep it cool and I guess, away from the light, but they accidentally drank it. I don't know how because it's super salty, but it happens all the time. So the best way to monitor your strength is by EC and not actually looking at the color of the fertilizer. So back in the day, we used to get a lot of questions about, my strength of the fertilizer. The concentrate looks robin's egg blue, and they knew when it was that color, that was the right strength. So that is not the case. So don't go by the color of the concentration. Stick with the electrical conductivity. All right. So to wrap it up, I did mention that the best way to monitor your fertilizer strength is to check what you're doing and measure well, but then also use your EC meter that hopefully you have in-house to check to see the reading that it matches. And let's talk a little bit about EC. EC is electrical conductivity. It's also known as soluble salt. It's an awesome indicator of how strong your fertilizer solution is at the end of the hose. So it really is a measure of the total dissolved solids that's in your water or fertilizer solution. But the thing that's important to know is that it considers both what is essential, those essential nutrients that we talked about in the beginning, and also the contaminants that were in your water or the other things. It's not always bad contaminants, but it's not important nutrients for the plants. And it does really give you a great estimate of your water's purity, but it can be written all different ways. So you'll see these lots of units. I don't know if it'll, yay, look at it spin, how exciting. So electrical conductivity can be given to you in all these different units, and they all mean the same thing. So a lot of times you'll see millimos or millisiemens per centimeter squared. So it's all similar kind of indications of the strength of that water or solution or fertilizer solution coming out of the end of the hose. It's super important for making sure what you think you measured into the concentration tank or into your reservoirs is exactly what is coming out into the hose. So here's an example just to look at. If you're checking your fertilizer strength, one thing that a lot of growers forget is to start with the EC of their water. Okay, if you're using RO water, you should have an EC of 0, right? Because you're paying all that money to take the water, take all the good and bad things out. And that's the only situation where you'll pretty much have a starting point of 0. Any other source water, there's going to be an initial soluble salt or an electrical conductivity reading. So in order to really understand what you're doing, you have to kind of consider your source water electrical conductivity at the start. So you see here's just an easy example. You check your EC of your source water, it comes out to be 0.04, and then you can check your EC at the end of the hose and it's 1.5. Well, don't go back to your bag to check if you're feeding parts per million on an EC of 1.5. You have to remember that you are already getting 0.4 of an EC from your source water. So just do that simple, easy subtraction. And when you're checking the EC kind of result that the manufacturer is telling you to, so if you're supposed to be getting an EC of 1 for 100 parts per million, you would just look to see, oh, I'm getting an EC of 1.1. And hey, it looks like those two match. So I'm actually feeding at the strength that I think I am. So that's just one of the common mistakes we see all the time when people are calculating their fertilizer solutions and kind of trying to, check it with what's labeled on the bag. So I appreciate everyone paying attention. I know this was fast and a little bit all over the place, but we're thankful that you tuned in this virtual environment. If you have any questions, please connect with us through our websites of JR Peters and jaxnutrients.com. Also, my email is here, and I'd be more than happy to have a conversation to help you dial things in at any time. So give me a little email shout, and that would be great. And if you're wasting time on social media like so many of us do, please follow Jack's Nutrients and J.R. Peters Inc. and see what the Blue Crew is up to. We were out there doing things, not so much anymore in the COVID environment, but we will be. So connect with us, connect with our communities, and let us help you get to know your fertilizer even better. Thanks a lot and have a great day.